So one of the favourite questions for examiners is to ask you about convergent plate boundaries. And for a lot of students, it's quite a worrying thing to write about because where do you start? There's a lot going on. The two plates are coming together. You've got earthquakes, ocean trenches, volcanoes. You've got two different types of crust. There's a lot to talk about, so we're going to go about how to simplify that process. Okay, so as with all of the explaining geographical processes on this spec, quite often it's 4 marks, and I would always, and I keep going on about it, always draw the diagram. It doesn't have to be that complex. In reality, something as simple as the one here. I'm not the world's greatest drawer, but this is fine. It's really easy to talk about sort of processes and features when you've actually got a diagram and you can label it with 1, 2, 3, 4 if you're sort of trying to explain where things are. You're trying to do this in a short period of time, so make it easy for yourself. So how would we start? So we can say an oceanic crust and a continental crust move together because of convection currents. So I haven't got the convection currents on here, and that's fine, but as we know, they'd be moving from the mantle and pushing it together because that's that sort of process by which plates are moving. And just at this point, come and have a look at the top tip bit. If I do a star over here, the oceanic crust is more dense and younger and less thick. Generally speaking, it's thinner than the continental crust and it's younger. It's being formed by dead plant and animal matter falling to the bottom of the ocean, being compacted. And it always gets subducted underneath, and we'll just write that on there. I haven't got it under the keywords, but at this point here, subduction, that just basically means being sort of forced underneath. So we've started off our process. Oceanic crust, which we know is less thick, it's younger, than the continental crust, and they move together. These convection currents are sort of forcing them together. A subduction zone, as I've just labelled on there, is formed because the oceanic crust is more dense than the continental crust, which we've just highlighted. And that kind of subduction zone kind of sits all the way on here. And that process is quite slow, but is kind of fairly continual. The oceanic crust is forced down underneath the continental crust, or subducted in the subduction zone, two are linked obviously, is melted, and magma is forced up through the cracks in the continental crust. But at the same time, obviously, when we draw pictures of this, it can sometimes be difficult to get your head round the fact that actually we're not just having two big plates sliding nicely against each other. These are sort of huge chunks of rock which are trying to be forced together one under the other. And you will remember from what we did in class, actually what happens is those rocks tend to lock in together and pressure starts to really build up as they're being forced together, and they can't move because actually the rock isn't sort of a nice straight line. This kind of line is actually kind of at this point here, those rocks start locking together and energy builds up and up and up, and we kind of know that actually if that energy is released, what we're probably going to get is an earthquake. So if it says here, if the magma is released at the surface, it creates a volcano which can be very explosive. And what can happen here is quite often the volcano is linked to the earthquake. So what will happen is, as we've said, the energy is building up to create an earthquake, and if that energy is released, actually it can make the volcano quite unstable, and that can actually create an sort of eruption itself. So the only other thing to add in there, which I haven't put onto theirs, is you can say, well, actually around about kind of 3 at this point, you can say actually the plates are locked in together, and that's actually building up the pressure ready for sort of an earthquake to be created and released if the pressure becomes too great, and you get this jolting sort of motion as sort of rock has been broken up by the energy.